Okay, so hello everyone again. This is lecture number 6 from Motion in a Plane. So in the previous discussion, we have completed with the initial starting of understanding the complete vector analogy in the motion in a plane. We also understood the complete vector propagation with an example also. Today we will be starting with the relative velocity in two dimensions, and let us understand how it is different from relative velocity in one dimension. So that thing being said, so this is lecture number 6, motion in a plane. I'm Samir Lawankar. Let's begin our discussion. Okay, so first of all, the course outline for you. So right now we are on the ninth topic, that is relative velocity in two dimension basically. Before this, we have completed with the introduction. The next was scalars and vectors, in which we understood the difference between what is a scalar, what is a vector, what are the different properties that vectors hold, why was there a need for introducing these vectors, etc. Then the third was again a property of vectors, that is multiplication of vectors by a real number. The next thing we understood that as vectors cannot be multiplied directly using the algebraic operations of plus, minus, divide, multiply. So therefore we understood one of the method, that is graphical method of addition of and subtraction of vectors. We also understood the triangle law of addition and the parallelogram law of addition. So both are gives the same result only, but are just different ways to understand this complete addition and subtraction of vectors. Okay. Next thing was resolution of vectors, in which we basically resolved any vector A into, let us say, if you are working with motion in a plane, into two components. So let us suppose this is a vector A. If you resolve it like this, so it is basically AX, and this is basically AY. Okay, so it's nothing but A is AX and AY. So it can be said as the vector A is nothing but equal to AX I cap plus A by G. Okay. Next thing was about vector addition, in which we understood the formula, that is the resultant vector is nothing but equal to under root of, let us say we are finding out the resultant of two vectors, that is A and B, plus 2AB cos theta. 2AB cos theta, where what is theta? Theta is basically the angle between these two vectors. So let us suppose this is vector A, this is vector B, which is starting from this location, and this is the vector, sorry, this is the angle theta between them. Okay, so this is nothing but also called as law of cosines. Okay, so that's how the resultant is being obtained. In the similar form, we also obtained tan theta also. So these are all concepts, and also the law of sines. So these all things can be understood directly in this vector addition analytical method. Okay. The next was about the motion in a plane. So we started with the motion in a plane, in which we understood how was motion in a straight line different from motion in a plane. So we basically used properties of vectors, etc. for, let's say, starting with the position vector. Then next was for displacement vector. Then next was for velocity vector, and the next was for your acceleration vector. Okay, so that's how we understood all these analogies, or basically the understanding of how these vectors can be implemented for motion in a plane. That thing being said, finally we went on to understand the motion in plane with constant acceleration, and again derived all the kinematics equation. So what was the kinematics equation? That B is equal to V naught plus AT. The second was the displacement vector R is equal to R naught plus V naught T plus half AT square. And the third was V square is nothing but equal to V naught square plus 2A into R. Correct? So this R is basically, all this can be R minus R. Okay, so that's how the three kinematic equations are being derived, and basically we can implement all of them. Now in this chapter, we will understand relative motion in two dimensions, and then we can move on to the two different concepts are remaining. One is the projectile motion, and next is the uniform circular motion. Okay, so let us understand the relative velocity in two dimensions first. So relative velocity in two dimensions is the next subtopic. Let us understand this. Okay, so when we started understanding the relative velocity in single dimension, what we said let us suppose this is an object A, and let us suppose we are standing on the ground. Let us suppose this is having some velocity which is denoted by VA. Let us suppose V moving also have some velocity VB. Quite evident the velocity of ground will be zero only, always, correct? So because ground is not moving. Okay. When we derived some formulas, the first formula was the velocity A is nothing but equal to velocity A with respect to ground. The second thing which we derived was velocity V is nothing but equal to velocity B with respect to ground. And third thing which we derived was velocity B with respect to A is equal to velocity B minus velocity A. Also, velocity AB is nothing but equal to velocity A minus velocity B. So what is this? This is velocity of B with respect to A. What is this? This is velocity A with respect to B. Okay, so that's how we understood the concept of relative velocity in two dimensions, in a single dimension. Okay. Why is this equal to velocity A? Because this can be also written as VA minus VG, and as VG is equal to 0, so this is equal to B. And similar goes from this scenario also, that this is equal to VB minus VG, and as VG is 0, this can be removed from. Okay. Right. So now let us understand what happens, or is there any change in the velocity in two dimensions. Okay. So the concept of relative velocity for motion along a straight line can be easily extended to include motion in a plane or in three dimensions. Now suppose that two objects A and B are moving with velocities VA and VB. Okay, so they are just saying that let us suppose this is some object A, let us suppose this is some object B, let us suppose this is moving with velocity VA and this is also moving with velocity B with respect to some common frame of reference. Let me draw the figures again. So let us say this is object A, this is object B, this is velocity A, this is velocity B, and let us suppose we are keeping the frame of reference on the ground. So this is basically the ground. Okay, and this is basically frame of reference. Okay, so what is basically frame of reference? The coordinate axis plus the clock can be understood as a frame of reference. Okay, so now suppose that two objects A and B are moving with velocities VA and VB, each with respect to some common frame of reference, say ground. Then the velocity A, the velocity of object A relative to that of B. How can we write this? That is velocity A relative to that of B is equal to, in the similar form which we understood in the single motion in a straight line case scenario also, that is VAB is equal to VA minus V. Okay. And similarly, the velocity of object B related to that of A. How can we write this? It is velocity B with respect to A. That is how it is written, is equal to velocity V minus velocity A. So you can see clearly that this is in similar terms as we understood in motion in a straight line. Not even similar, it is the same one. Okay. Therefore, velocity AB is equal to minus VBA. Quite evident, you can see from these two equations that velocity AB is equal to minus velocity B. Okay, and therefore the magnitude of VAB is equal to magnitude of VB. So this is quite evident when the direction is reversed for both these vectors, the magnitude is the same. Okay, fine. So now let us understand one of the examples of this relative velocity in two dimension, and let us move forward. Okay, so one thing what can be analyzed is, as we understood in another examples also, the velocity vector in single dimension. In single dimension was basically, let us suppose, in this direction, or let us say it is in this direction, or let us say it is in this direction. Correct? What is the only addition which is being done here right now when we are finding, or when we are writing VAB is equal to VM minus VB? So in two dimension, only thing which is being changed is this velocity vector is divided into two components, such that we are working with Vx also and we are working with Vy. So this can be said as that relative velocity concept is generally divided into two divisions, so that once you will work in x, once you will work in y, and we can just write something in I cap plus something in j cap, and then we can basically study the relative velocity in two dimensions. So that is the only change, that is the only addition. The rest, all the concept of the basic concept of relative velocity is same. Okay. So let us understand this relative velocity in two dimension with an example here. So rain is falling vertically with a speed of 35 meter per second. So this is the velocity, this is the direction of the rain. We can write the rain as nothing but VR, which is equal to 35 meter per second. Fine. A woman rides a bicycle with a speed of 12 meter per second in the east to west direction. So please remember, this is your north, this is your south, this is your west, and this is your east. What is the direction of the bicycle? It is east to west. Okay. So hence this will be east to west. So this will be the direction. Okay. So I can put the vector here. So this is the velocity of woman, or the velocity of bicycle, which is nothing but equal to, so this is this which I am talking about, correct? So this VB is nothing but equal to 12 meter per second. Fine. Now, what is the direction in which she should hold her umbrella? Okay, so if you remember correctly, we also did similar type of question in the previous example also, when we were trying to understand the basic analogy of vector addition. Now let us try to solve the same example using relative velocity concept. Okay, so let us understand whatever is written here. It's a very easy problem, only an analogy is being changed here. Okay, so just a perception of how we see the example, see the question is being changed. The example is same, the answer would also be same. Okay, so in the figure, VR represents the rain. As you can see, this is the rain basically, and this is the velocity of the bicycle. Okay, now both these velocities are with respect to ground. Quite evident that I also explained to you in the previous only, VAG is equal to VA, and similarly VBG is equal to VB. So therefore we can also write VR is nothing but equal to VRG, and VB is also equal to VBG. Why? As VG is equal to VB. Okay. So now let us see whatever is written. So since the woman is riding a bicycle, the velocity of rain as experienced by her is the velocity of rain relative to the velocity of the bicycle which is riding. Just think about it. If you think very clearly, you can obtain directly. So this is basically intuitive result here, that whatever the thing which I am experiencing or is only and only can be explained if I am the frame of reference. So that is the thing which is written here. So let us suppose that we need to see that how the woman is seeing the rain. So woman will see the rain with a velocity which is relative to the woman, correct? So this will be the thing which we need to calculate. That is the velocity of rain with respect to the bicycle. Okay, so this is the intuitive part here, which only differed it with the same analogy which we understood in previous example. Some previous example when we are understanding the concept of error, when we are understanding the concept of addition and so on. So therefore, we can write VRV is equal to VR minus VB. So this is a simple relative velocity formula, that is velocity of rain with respect to bicycle is nothing but equal to velocity of rain minus velocity of bicycle. Okay, so just try to calculate this value. So when you will try to calculate this value, what will you get? You will get the relative velocity vector as shown in the figure makes an angle theta with the vertical. This is the angle theta. Okay, So I think the question asks only about direction. They are not asking about magnitude. So therefore, just simple use of tan theta. So tan theta is nothing but equal to VB by VR. What is the value of VB? It's 12. What is VR? It's 35. That gives you 0.343. When you will calculate theta is equal to tan inverse 0.343, you will get the answer approximately equal to 90 degrees. Therefore, what is the final result? The final result is that the direction in which the lady should hold the umbrella is towards the east, with an angle of 90 degrees with the vertical. Okay, so that is how you can obtain this similarly. So that is the expression, or that is one of the example in which we understood basically how the relative velocity in two dimension is taken into consideration. So you can remember, you can quite clearly see here that how it is a question of two dimension, because one is in, let's say, x direction and another velocity was in y direction. So that's how we take into scenario an example of xy case. If both would have been in the same direction, or let's say both would have been in this direction, then the concept would have been in relative velocity in single dimension. Okay, that is how you derive at the result, and therefore it is theta is approximately equal to 90 degrees. Fine. Therefore, the woman should hold her umbrella at an angle of 90 degrees with the vertical towards the west. Okay. Note carefully the difference between this and the example 4.1. So that was the example which you understood. In example 4.1, the boy experienced the resultant of two velocities, while in this example, the woman experienced the velocity of rain with respect to the bicycle. Okay, so this was the only. So there is just an analogical part, how we understand the situation. That's all. So here, the boy experienced the resultant velocity, while on the example here, the woman experienced the velocity of rain related to the bicycle. Okay, so that is the only difference. In that, it was being asked what is the new velocity of the rain, and here it is asked that what should be the direction of the umbrella. There also umbrella was being asked, only the analogy is being changed. So there we did vector sum, and here we did relative addition, or basically the relative direction of holding, or the relative velocity of rain with respect to your bicycle. Okay, so that thing being said, let's move on with the new subtopic, that is projectile motion. So everything about understanding of vectors is being explained. So we understood vectors also, we understood equations regarding your kinematics also, right? We understood motion in a plane also. Now let us put everything in our test result and understand the projectile motion. So this is one of the basic explanation or basic understanding of vectors. If you understand projectile motion very clearly, then you have understood the basics of vectors and equations and motion in a plane. Okay, so let us start a new subtopic. Now please put all the attention here, because majority very new formulas will come up here. Kinematic equations would be used. We will use it directly in the examples. So therefore we should understand how these equations have been derived. Okay, fine. So let us start projectile motion. So what is basically a projectile? So to explain you very clearly or in a very easy terms, let us suppose this is your XY plane. And let us say we have a ball being kept here. If I throw the ball with some velocity v in this direction, so because g is acting in this direction, the motion or the path of the ball is some sort of this. So this is the path. This path is nothing but called as projectile motion. Okay, so now here we try to understand different scenarios, as in what is the time required for the movement from, let's say, this to this place, or let's say this to this place. What is the height? What is the range? So these all things will be covered. Okay, so let us try to derive everything, and then we can move on to further discussions. Okay. So as an example of the ideas developed in the previous sections, we now consider the motion of a projectile. So now let us try to understand the motion of a projectile here. So an object that is in flight after being thrown or projected is called a projectile. Okay, so basically, an object that is in flight after being thrown or projected is called as a projectile. It is being thrown like this, and hence it is called as a projectile. Okay, so such a projectile might be a football, cricket ball, or baseball, or any other object. So this object can be either any of this. It can be a football also. It can be a cricket ball also. It can be a baseball also. It can be any other object also. It can be a rock also. Even it can be you also. If you can be streamlined, so that the air resistance is very negligible upon. Okay, so you also follow the path of a projectile only. Okay, so the motion of a projectile may be thought of as the result of two separate simultaneously occurring components of motion. Now, this is a very important line. In all the previous concepts which we studied about resolving of vectors, or let us suppose about the equations of motion in a state, equation of motion or in 2D plane, all these concepts, what was the basic idea? That a vector can be resolved into two different components, let us say in Vx and Vy, and there was in these both were independent of each other. So anything which is happening in this direction does not have any effect on what is happening in this direction. And finally, what we can do, we can basically add both these together in vector form and can obtain V and let us say theta at any time t. So that was the basic crux of understanding the initial portion, that is that the motion of a projectile may be thought of as the result of two separate simultaneously occurring components of motion. Okay, so this is quite idea that at some time t is equal to t, there would be some velocity in x, there would be some velocity in y, but there is no relation. Let us say that vx is something 1.2 times velocity y. So there is no relation like this which can be obtained. They are independent of each other. So that is the building block, or that is the starting point of projectile motion. Let's move forward. Okay. So one component is along the horizontal direction, quite evident. One is along this direction, that is x, which is without any acceleration. Quite evident, because we know that only and only acceleration which is being put forward is in this direction, which is g. Okay, and because the initial velocity is being put in this direction with some v, there is no acceleration which is being done on the x-axis, because the question is being framed in this way that acceleration is only and only due to a force which is being acted by earth, and that is only due to gravity. And because gravity only acts in vertical direction, there is no component of it along the x-axis. Therefore, the acceleration along the horizontal direction is zero. Or else what we can write, ax is equal to 0. Okay, fine. And other along the vertical direction with constant acceleration due to the force of gravity. So for this, what we can write? We can write ay is nothing but equal to minus g. Okay, so that's how we can understand ax and ay. Okay, so we know what is a. A is nothing but equal to ax I cap plus ay j cap, which is equal to 0 I cap plus minus gj cap. Therefore, acceleration is equal to minus g j cap. Okay, fine. So it was Galileo who first stated, so he was a prominent scientist, Galileo was a prominent scientist. It was Galileo who first stated this independency of the horizontal and the vertical components of projectile motion in his dialogue on the world grid system in 1632. So in our discussion, we shall assume, please remember, very important line. In this, we will assume that air resistance has a negligible effect on what? On the motion of the projectile. Okay, so the only and only external force which is happening is due to the air resistance and nothing of another of that sort. Okay, so please remember, this is one of the assumptions being put, that air resistance is negligible. Okay, fine. Let's move on. So now let us try to understand the situation. Let me first explain you whatever is drawn. Okay, so first look at the diagram. The diagram states that there is a projectile with the blue color with an initial velocity v0. Now if we drop the perpendicular from here, we can obtain the components of the velocity v0 in the x and y direction. So what is the component of the velocity v0 in x direction? This is nothing but equal to V naught. If this is cos theta naught, as you can see the angle of projection. Okay, so what is this theta naught? What is this theta naught? Theta naught is nothing but angle of projection. Okay, so V naught x will be nothing but equal to V naught cos theta naught. Quite clear? So simple trigonometry, and we calculated V naught x is equal to V naught cos theta naught. Similarly, the projection here will give you V naught y, which is equal to V naught sin theta. So I hope it is quite clear how we obtain the initial velocity components of the vector V naught. Okay, fine. Let us understand whatever is written here. So suppose that a projectile is launched with a velocity v naught. Okay, so what is the initial velocity with which it is launched? It is v naught. That makes an angle theta naught. That makes an angle theta naught with the x-axis as shown in the figure. Fine. Next thing, after the object has been projected, the acceleration acting on it is only due to gravity, which is directed vertically downwards. Therefore, what you will write? We will write A is equal to minus dj. I think I derived it here also. What is the acceleration value? It is minus dj. Okay, fine. So we got the acceleration is equal to minus dj bar, where ax is 0, ay is minus g. That is also we derived here. So ax is 0, ay is minus g. Okay, so we understood till this point. Let's move on. So the components of initial velocity v naught are, so v naught x is equal to v naught cos theta. Similarly, v naught y is equal to v naught sin theta. Okay, that is also we understood. Now, if we take the initial position to be the origin of the reference frame, that is, we start the projection from, let us say this as the origin, or this as the initial position is taken as the origin. So if we take the initial position to be the origin of the reference frame, what can be said? It says that the initial value of displacement in the x and y direction is 0. So therefore, what we can write? X naught is 0 and y naught is also 0. Or else what we can write? Not x. We can write what is the position vector at initial position? R naught is equal to 0 I cap plus 0 j. Clear? Okay. So here we are clear till this position. Okay. So we got the acceleration value. We got the initial value of velocity in x direction. We got the initial velocity in y direction. And we got the initial displacement in x and y direction. Okay. Now let us start using the kinematics equation. Okay. So the first kinematic equation, now because we can use these equations in simultaneously for x and y, so just by substituting the velocity values or the component values of x displacements in with x and y, we can obtain the results. Okay, x, y, vx, vy, depending upon whichever axis you are talking about. So let us say we are talking about x-axis first. So we know what is x. X is equal to x naught plus v naught x t plus half a x t square. Correct? So this can be equal to x. We know what is initial displacement. Initial displacement is 0. This is equal to 0 plus v naught x. What is v naught x value? It is v naught cos theta naught into time plus, we know what is the initial acceleration value in the x direction. It is 0. So this will be 0. So therefore, x is equal to v naught cos theta naught, which is into t, which is being obtained. Okay. So x is equal to v naught x t equal to v naught cos theta naught into t. Okay. So that's how we derive the first result. Now let us look at the second result. So what does this line say? This line basically says that that is how the displacement of x will occur as the time moves. Okay, so that is how the velocity of x, or sorry, the displacement of x will occur depending upon. So as we know, v naught is a constant value, correct? Cos theta naught is also constant value, only time will change, and that is how the displacement will change. Okay, now let us derive the displacement in y direction. So we know what is y. Y is nothing but equal to. So these are simply kinematics equation I am using. Okay, nothing new here. So y is equal to y naught plus v naught yt plus half ay t square. Okay. So now just putting everything here. So it is y, which is equal to, what is the value of y naught? We know it is equal to 0. So 0 plus what is v naught y? V naught y is this form here. So it's v sine theta naught into time plus half into minus g. Please remember, ay is minus g, correct? Into t. So therefore what we got? Y is equal to v naught sine theta naught t minus half gt square. So that is the relation here, and hence which we found for here. So from here also what we can say, that first of all v naught is a constant, sine theta naught is a constant, t is a variable, half is constant, g is constant, t square is a variable. So here y again depends upon t in this fashion. So it's basically a quadratic form, and this was a linear form. Okay. So I hope it is clear till this position. So what is the final conclusion? We finally concluded that we got a relation between x and y as we move forward with time. Okay, that is the equation, or let us say that is the equation of motion of a projectile motion. Okay, let's move forward. Now, what are the components of velocity at time t? So this v naught was the velocity at initial at time t is equal to 0. So let us try to find out the velocity at some time t. Okay, so how to obtain them? How to obtain them? I think we have obtained this earlier. Okay, now we know that what is, we will use another, and again we will use kinematics equation. So you know that velocity at some final point x is nothing but equal to initial value plus ax into t, correct? So as we know, what is the initial value? It is nothing but equal to v naught cos theta naught plus what is the initial acceleration? What is the acceleration at x direction? It is 0 into t. Now what is the velocity obtained? It is equal to v naught cos theta. If you see, this is the thing which you obtain. That is vx is equal to v naught cos theta. Let us try to derive it for the y case scenario here. So again, using the first kinematics equation, in the y direction, what we will say? We will say vy is equal to v naught y plus ay into t. This is equal to, what is v naught y? We know v naught y is nothing but v naught sine theta naught minus g, because ay is minus g, into time. Therefore, vy is equal to v naught sine theta naught minus gt. And hence this is the derivation of v naught sine theta naught minus gt. Okay. Fine. Let's move to the next point here. So equation on the previous slide gives the x and y coordinates of the position of a projectile. Please remember what is written. The equation on the previous slide. So this was the these are the equation we talked about. So equation on the previous slide gives the x and y coordinates of the position of a projectile. Correct? So they tell the position of a projectile at some time t in terms of two parameters. So what are those parameters? Basically, if we know the value of initial speed v naught and the projectile projection angle theta. Okay. And what does this point tells us here? It just tells the same thing, but it doesn't tell the position. In the place of position, it tells you the velocity. Okay, so it tells you the velocity, basically vx and vy, and therefore we can find out the velocity by directly doing under root of vx square plus vy square, and tan theta is equal to vy by vx. From this we can find out the velocity, magnitude, and direction. Okay. Notice that the choice of mutually perpendicular x and y directions for the analysis of the projectile motion has resulted in a simplification. So because we are using these perpendicular x and y, it has simplified our complete analogy, complete analysis of understanding the projectile motion. So one of the components of velocity, that is the x component, remains constant throughout the motion. As you can see, let me rub everything and let us see clearly. If you see the Vx position clearly, it is just V naught cos theta naught. Hence, what we can say that as well, V naught is also constant, cos theta naught is also constant. Therefore, Vx is constant throughout the motion of projectile motion. Therefore, one of the components of velocity, that is x component, remains constant throughout the motion, and only the y component changes. Why y component changes? As you can see, it's a function of time. Okay, like an object in free fall in vertical direction. Okay, so what we can assume that velocity this is having. So how we will do the question solution here? We'll assume that, let us say, this is the ball which is having velocity v. It can be done with two simultaneous equation handling. In one, we can assume that this is the same ball with a velocity vx in this direction, and again this is the same ball with the velocity vy in this direction, and try to understand the complete process. Okay, so this is shown graphically at few instants in the figure. So that is how a projectile motion is being drawn. Okay, so at every time the velocity v keeps on changing and changing. So it first observes this fashion and then goes up. So note, at the point of maximum height, at this point, the values of velocity vy is 0. This is similar to this case scenario. Let us suppose we had a ball and we sent it upwards. So first of all, it was having some velocity, let us say vy. It went till the highest position and then it dropped. So if it is dropping from the highest position, then at the highest position, what is its velocity? The highest position velocity is 0. And that is the same analogy which is in put forward. Okay, so note that at the point of maximum height, vy is 0, and therefore tan theta is equal to tan inverse vy by vx, which is equal to 0. Okay, so that's how this case scenario occurs. Let's move forward. Okay, so now let us try to derive the equation of path of a projectile. Okay, so please understand this now. So first of all, what is the shape of the path followed by the projectile? That can be seen by eliminating the time between the expressions for x and y in the following equation. Okay, so basically this is one of the methodology we will understand in mathematics also, that is called as eliminating the common coefficient, common variable. Okay, so that is how if there are, let us say, three variables. Okay, so and we have, let us say, in here we have two equations, correct? So somehow the methodology can differ also. So if we need to remove one variable, what we basically do, that we try to make a function of one thing with this and put this in the second equation, so that we can obtain only and only equation which is valid in x and y, or basically two variables. Okay, so you will understand more clearly about this methodology in the mathematics. I will try to derive this for this part. Okay, so that is how we obtain to this result. Okay. Okay, so here x is equal to v naught cos theta naught into time. From this relation, what we can say? We can say that t is equal to x upon v naught cos theta naught. Okay, so this was the first relation which we obtained, that is t is nothing but equal to v naught cos theta naught. Okay, now what was the second? So these are nothing but the equation which we derived previously, right? So there is nothing new here, only these relations are being put forward there. Okay, so what is y basically? Y is nothing but equal to p naught sin theta naught into t minus half g t square. Okay, so just put the value of t is equal to x upon v naught cos theta naught here, and then we can finally derive at the equation. Okay, so what is basically y? Y is nothing but equal to v naught sin theta naught into x upon v naught cos theta naught minus half into g into x upon V naught cos theta naught whole square. So y is nothing but equal to V naught will get cancelled. Sin theta naught upon cos theta naught will give you tan theta naught into x minus g by 2 into V naught cos theta naught whole square into x square. Correct? Hence, this is the equation of a projectile. Okay, so y is nothing but equal to tan theta naught into x minus g by 2 into V naught cos theta naught whole square into x square. So that is how we obtain the equation of path of a projectile. What do we obtain? We obtain the equation of path of a projectile. Right? So that was a small derivation regarding this. Now, since g, theta naught and v naught are constant, so whatever are constant, this is constant. Value of theta naught constant, and this is a constant, and v naught is a constant. So therefore, this complete thing is also a constant. Okay. So the above equation is of the form what? It can be written as, so in the place of tan theta naught, so we assume A is equal to tan theta naught and B is equal to G by 2 into V naught cos theta naught whole square. So therefore what we can write is, we can write as y is equal to some AX, we write minus here also, plus B into x square. Okay, this is the form of equation which you obtain. Okay, in which A and B are constant. Okay, this is the equation of a parabola. That is the path of the projectile is a parabola. Okay, so in the further mathematical analysis, you will understand about motion, pair of straight lines, then circle, then parabola, then hyperbola. Okay, so when you will look at the analysis here, I won't go into detailing of why it is a parabola. You will understand each and every concept there. Okay, so that's how we understood this result, that it is of the form ax plus bx square, and hence this is the equation of a parabola. Okay, so this thing will be much clearer when you will understand these concepts in mathematics. Okay, fine. So that thing being said, what is the final conclusion of this part of the slide? The first is that this is the equation of path of a projectile. And what is the equation? This equation is a parabola, and that is why the form of path is basically a parabola. The path form is basically a parabola. Okay, fine. Let us move forward. Now let us understand the time of maximum height. Okay, so what does it mean by time of maximum height? You can understand this from the thing which is written here only. So the time required for the object to move from this location to the maximum height location is called as time of maximum. Okay, so now let us try to derive it. How can we derive it? So the correct method can be to say that as we know that we can resolve the velocity components in x and y direction, the time would be same either we calculate from t or we calculate from y. Now, because the velocity in x direction is not dependent on time, but the velocity in y direction is dependent on time, the time which we obtain from this location can directly be used for our analysis. Okay, let us try to use this and understand the time required. Right, so let this time be denoted by Tm. Since at this point Vy is 0, okay, so we know quite evidently the velocity of Vy is 0. So let us use this relation here. Now we know velocity for in y direction is nothing but equal to initial velocity in y direction minus gt. Correct? What is the final value? It is 0, which is equal to, what is the initial velocity in y direction? It is equal to v naught sine theta naught minus gt. So in this relation, we can obtain v naught sine theta naught is equal to gt. Hence, this t, which is equal to tm, is equal to v naught sine theta naught by g. Okay, so that is how we obtain the time of maximum height is equal to v naught sine theta naught by g. Okay, I think it is clear. Now let us understand more about this. Okay, so as this is a parabola which is symmetric, As this is a parabola which is symmetric, what is the total time required for an object to go from this to this location? If this is symmetric and this is at the midsection, okay, then the complete time required, which is known by TF, is nothing but equal to 2 times of TM. What was TM obtained? It was equal to V naught sine theta naught by G. And so what is TF? TF is nothing but 2 V naught sine theta naught by G. Okay, so that was the total time required for your projectile for the complete motion from, let's say, if this is ground, from ground to ground. Okay, so now let us understand whatever is written here. So let this time be denoted by Tm. Since at this point Vy is 0, so as you can see the velocity of Vy, the value of Vy is 0. So we have from equation Vy, which is equal to V naught sine theta naught minus Gt. We have Tm is equal to V naught sine theta naught by G. Now the total time Tf during which the projectile is in flight can be obtained by putting y is equal to 0 in equation this. So either this can be solved from this relation also. Let us try to release this from this equation. So equation. So this was the same thing. Path of projectile in y form, that is v naught sine theta naught into t. So any equation which I am using directly are basically derived in the previous slides only. Okay, so I am not using anything new. I'm just using simple kinematics equations only. Okay, half gt square. Okay, so what they are saying, just put the y equal to 0, because as you can see that the displacement is 0 here, correct? So if you put that into scenario, it will be y v naught sine theta naught t is equal to half gt square, correct? If we cancel t, okay, because t is t not 0, t, the value of t which is not 0 is to be used here. Therefore we will get the value of t is equal to 2 v naught sine theta naught by g. You will see clearly this is the same scenario which you obtain, which is equal to 2 into v naught sine theta naught by g. This time Tf is called as time of flight. Keep on remembering these words also, because this will be directly used in the questions. So what is the time of flight? Time of flight is nothing but the total time required for the projectile to reach from, let's say, ground to ground, or let's say from its initial position to the position at which the displacement is again 0, is called as the time of flight of the projectile. We note that Tf is equal to 2Tm. Okay, so now this is quite clear. We can see quite clearly. That is Tf is equal to 2Tm, which is expected because of the symmetry of the parabolic path. So because of symmetry of the parabolic path, it is expected that the value of Tf is equal to 2Tm. Okay. So that thing being said, so let's understand the final concept for this lecture, that is the maximum height of the projectile. Okay, so what is the maximum height of a projectile? The maximum height hm. So basically what we're talking about here, we are talking about this height. Okay, so the maximum height hm reached by the projectile can be calculated by substituting t is equal to tm in equation. So what we are just doing, again we are using the displacement equation in the y direction, that is y is equal to v naught sine theta naught into t minus half g t square. Okay, so what you are basically doing, we are just substituting t is equal to tm here. So we know that at this location, what is the value of t? T is equal to tm. What is tm? Tm is basically v naught sine theta naught by g. Okay, so now let us try to derive it here. Okay, so what is y? Y is basically v naught sine theta naught into v naught sine theta naught by g, correct? Minus half g into v naught sine theta naught by g whole square. That will lead to, this will be equal to v naught sine theta naught whole squared by g minus half of V naught sine theta naught whole squared. So G square and in numerator G, so 1G will get cancelled. This will be equal to G. Because these are both in the same scenario, what we will obtain? This value of Hm, which is equal to Y here, is equal to V naught sine theta naught whole squared by 2G. Okay, so that is how we obtain this result here. So this will be 2G. Okay, therefore the final result which you obtain for Hm is nothing but equal to V naught sine theta naught whole square by 2G. Okay, so that's how we obtain. So how we obtained? We just put the value of T is equal to Tm here, and therefore finally we obtained that is V naught sine theta naught whole square by 2G is the maximum height of the projectile. This is the maximum height we talked about. Okay, so let us just revise these scenarios and then we can move with the further discussions regarding the range, etc. in the next class. Okay, just revising the projectile motion because several new things have come up here. So first of all, we started with acceleration. That is, acceleration is equal to minus gj bar. Correct. The velocity was being directly resolved into two components. That was, let us say the velocity is v naught in this direction. Therefore, this is equal to v naught cos theta naught and v naught sin theta naught. We assume that we are talking with the origin of the reference frame. Therefore, x naught is 0, y naught is 0. Now, just simple mathematical calculations using kinematics equation gives us this result. Similarly, we got this using the first kinematics equation. So this was obtained using the second kinematics equation, and this was observed using the first kinematics equation. Okay. Then next thing was about these all things were being explained. Okay, when we understood the equation projectile of motion, how we obtained this? We just substituted the value of t from this equation into this. Okay, so we use just the value of t obtained from equation number 1 and put in equation number 2, and finally we obtained this form for the equation of path of a projectile. We obtained that this is a equation of a parabola. Then we obtained the time of maximum height. So Tm came out to be equal to V naught sin theta naught by G, and total time came out to be 2 V naught sin theta naught by G. This is also called as time of flight, and capital Tf is equal to 2T. Next thing is, finally we obtained the maximum height of projectile, which is equal to V naught sin theta naught whole square upon 2G. Okay, fine. So let me stop the discussion here only. In the next class, we will go on with the further discussions. We will understand range, etc. And then we can move on to some of the examples related to it. And then finally, we'll go with uniform circular motion. Okay, so the course progress for you. We started with the introduction, then scalars and vectors, then multiplication of vectors by real numbers, then addition and subtraction of vectors, graphical method, then resolution of vectors, then vector addition, analytical method, then motion in a plane, then motion in a plane with constant acceleration, and we understood relative velocity in 2 dimensions, and finally right now we are on the 10th topic, that is projectile motion. After it is completed, we will move on to uniform circular motion, and that will be the end of motion in a plane. Okay, so thank you so much. We will meet in the next lecture.